welcome to H2O Stream. This is Martin reporting for H2O Global News. Treating wastewater is an essential part of reusing a precious resource. Companies and municipalities face ever stricter regulations on what they can discharge. Just as importantly, they face pressure to reduce greenhouse gas emissions, so they need to install ultra-efficient systems. One of these is Aquacycl's Bioelectrochemical Treatment Technology, the BETT system. So we welcome Orianna Bretschger, founder and CEO, who is going to tell us more. Hi Orianna, how are you?
Hi, I'm doing well. How are you, Martin?
Not too bad, getting by. So to make us start, could you give us some background about yourself and your company?
Happy to. Yes. So I am the CEO and founder at Aquacycl, but I'm coming from academic background. So I started researching the technology which we're commercializing. Now the starting point was in 2004. So it's a nearly 20-year journey for me, taking from small-scale lab experiment through additional development in the not-for-profit space, and then finally launching Aquacycl in November of 2016 to commercialize what we had developed. So it's been very exciting as a researcher to really see something come from the lab to solving customer problems.
Excellent. So I suppose the next logical question is, how does BETT work?
So yes, BETT, our Bioelectrochemical Treatment Technology. So it's based on a microbial fuel cell. And what we do is we create an environment in our little reactors, our BETT reactors. And these reactors are about the size of a car battery. But this little reactor, it creates the environment for bacteria to form biofilms on the internal surfaces. And what we're selecting for are specific bacteria in that biofilm that has a capacity to use the electrode, not only as a place to live, but also as a way to breathe or a way to respire. And so in this process of respiration, the organisms that we're accumulating at that surface have the capacity to move electrons from inside the microbial cell to outside and discharge those electrons to the environment. And so we capture those electrons on the conductive surface, we move them across a circuit, generating DC power. And the faster we move electrons away from those bacteria, the faster we're forcing those microbes to breathe and respire, and therefore the faster they eat. So more electrical current generation means a faster treatment rate. And so that's the innovation in the space. You know, we're not fixing CO2 to methane. We're not consuming oxygen to additional biomass. It really is a different respiration process, but still taking advantage of natural microbial systems.
It's very clever technology. So what pollutants does it remove?
It loves organics, anything organic. So this can be sugars, it can be fermentation products like volatile fatty acids, it can be starches, complex carbohydrates. In addition, we have some new work that we've been looking at. We can also remove long chain hydrocarbons and aromatics, so things like benzene, toluene, naphthalene, ethers, some pretty challenging stuff, even gasoline and diesel. And so we've been able to show same approach, enrichment approach, probably different bacteria, but they're able to consume these organics, all the way ultimately converting those complex organics or sugars into dissolved bicarbonate, electrons, and protons.
Excellent. So moving on, what are the advantages of the technology, especially when you compare it to the sort of more traditional wastewater?
So to my knowledge, this is the only anaerobic approach that can actually address hydrocarbon remediation. Most aerobic processes can, but those require very large footprint physically, lots of energy consumption, and also doesn't necessarily address all of those nasty compounds, the aromatics and long chains that you need to get rid of. So that's one niche. But also the advantage that we bring against anaerobic digestion and more conventional approach, like food and beverage, is a very small footprint. So we containerize our BETT units, right? And we stack them together like Legos inside a standard shipping container. And depending on the flow volume that we need to process, We can have multiple shipping containers, or we just rack up the reactors inside of a building as needed. And so this gives us the advantage of being able to address some smaller scale applications that are still very challenged in potentially, wastewater management costs, etc. But they wouldn't go necessarily to an anaerobic digester because it's expensive and big. Additionally, complex. Anaerobic digesters have been around for a while, and there are some amazing operators that know how to make these things hum. But a food and beverage plant operator, they're focused on making their product. They are not necessarily, an anaerobic digester whisperer. And so it can become very challenging for non-expert operators to run anaerobic digesters, because the fluctuations in temperature and volume and pH can all impact efficiencies and even crash the system if something off of your production line goes wrong, or it's different than what the AD is used to seeing. And so we handle all of those challenges. We can handle the fluctuations, changes in volume, changes in concentration, even plant shutdowns for weeks at a time, because we have the ability to maintain the biofilm, operate the system in batch, which we flip the switch remotely. We don't need a physical operator there to do it. And so we really simplify the process for that process for the producer.
That's excellent, because I know a lot of them do like to have something they can just plug and play and let somebody else deal with it. And so you've answered the question that it's scalable, basically just stack it like a Lego. But a lot of people now are panicking, trying to sort of fulfill the new strict water regulations. So can they just retrofit?
Yes, absolutely. So we do not rip and replace. So anything that is already existing, whether it's an anaerobic digester that may be not necessarily performing to the spec you wanted, or an aeration or membrane bioreactor approach that might be on site already. Our goal is to take the tough stuff, so whatever's already installed can operate with greater efficiency, less energy, less sludge, a secondary sludge production, and overall simplicity.
Excellent. So we'll move on to the sort of the carbon emissions. So why does wastewater treatment have such a large carbon footprint, and how does your technology reduce the gas emissions?
Yes, thank you. So wastewater treatment has a big footprint because there's a lot of points along the treatment scheme that either are generating methane and CO2 directly, or are requiring a massive amount of energy, and most of that energy is still supplied by coal-fired plants. And so when you look at what happens to wastewater when it goes down the drain, you have a lot of pumping stations requiring a lot of electricity, sending it to a centralized treatment plant. Then that treatment plant has, assuming it's a conventional activated sludge approach, is going to be pumping air into water. And depending on the size of the plant, just that activity alone can consume 60% of the entire plant's energy budget. Then you've got your waste activated sludge that you have to separate out, that potentially hauls off into a separate digester, or could be on site, but it can also be hauled to a landfill where it breaks down and generates more methane and CO2 emissions. So everywhere along the process in a conventional sewage and centralized approach, you've got a lot of opportunities for emissions, but also opportunity to reduce emissions if you do point source remediation ahead of sewer discharge. And that's where we come in. So our energy consumption on a single 40-foot shipping container, standard size Connex unit, only requires 60 kilowatt hours a day to operate. And we're removing anywhere from 800 to 1,600 kilograms of biological oxygen demand every day with that energy budget. It would take 2,500 kilowatt hours a day on a conventional activated sludge approach to treat that same, load. And so when we're point source remediation, we take out a lot of carbon with very little energy, and we also produce a little bit of DC power, which at some point maybe can be recovered to be a fully energy neutral system for addressing some of the real challenging waste streams that evolve as point source polluters.
Yeah, that's a very impressive reduction. What do you think the biggest challenges you face whilst developing BETT?
So from a technology side, looking back, that was easy. At this point, it's developing the business, right? Really understanding the value that we bring, understanding the challenges that we can address, and connecting our solution to the customer, in the most efficient way. And so, we're learning much more about every market that we serve, which is great. So it's always, I love talking to our customers and better understanding where their challenges are, and then being able to adapt that technology specifically, right, to address that problem. So that part of it is fun, but from a new technology adoption perspective, in water and in wastewater, right, it's slow. It's a risk-averse industry, as it should be, but it becomes the biggest challenge is getting a new technology adopted quickly.
Yeah, that's always the way. One thing I noticed when researching your company is that you're great believers in a multidisciplinary approach. Why do you think this is important?
Well, as a global community, we face some really big, complex challenges. Climate change, and water is a huge part of climate change and how we feel it. You have too much water, too little water, how we're treating water, moving water, generating more greenhouse gas emissions to be a very negative circle. And the way that we can achieve a truly circular economy in a positive way, right, is really taking in different viewpoints, from outside your specific industry. Because there's a way that you're taught, there's a way that you do it, but that might not always be the best way or the right way. And so when you bring in somebody who's not integrated so deeply into that same problem space, they have a different viewpoint and may ask questions that you never thought of. And so to us in development, as well as even in sales, it's really important to have that diversity of thought and that extra set of eyes, and also, just a way to more broadly address these complex problems.
Yeah, certainly. I think it's certainly a good way of making sure you don't fall into groupthink, which I think is often the downfall of many new companies. Yeah. So moving on to that, so what are your plans for the future?
Well, the world domination on wastewater treatment. So plans for the future. So it's very excited to share. We just opened offices in the Netherlands, and so working with partners there at the Water Center, we're setting up a test center where we can start accepting and evaluating European samples, and ultimately growing our business in the European sector to help address current and changing regulations in the wastewater space. So super excited about that as a near-term advance.
Excellent. Yes, that's interesting to know. So I think that's everything for now. So I'd like to thank you very much for your time. It's appreciated, and I've learned a lot. Thank our audience for listening, and that's thank you very much and good night. Thank you.
Thank you. My pleasure.